Welcome to our module on database management, where we will focus on working with MongoDB. We will explore mastering NoSQL databases using Mongoose and understanding powerful aggregation techniques. Let us begin by looking at the key features that define NoSQL databases. These databases are specifically designed to address the complex challenges of modern data management. First, NoSQL databases offer a schema-less structure for your data. This means there is no predefined table structure, giving you immense flexibility in how you store information. Next, we have horizontal scaling, which is a significant advantage. It efficiently handles large data volumes by distributing them across many servers, ensuring high availability. Another crucial feature is their inherently high performance. NoSQL databases are optimized for very fast read and write operations, perfect for large-scale applications. Finally, they support various data models, offering great versatility. This includes document, key value, column family, and graph database types for different needs. Now, let us categorize the different NoSQL data models available to us. Understanding these diverse data storage approaches is crucial for choosing the right tool for your project. First, we have document-based databases which are quite popular. These store data in JSON-like documents, with MongoDB being a prime example of this type. Next, consider key value stores offering simplicity and speed. Data is stored as straightforward key value pairs, a model famously used by Redis. Then, there are column family stores, which organize data differently. They arrange information by columns rather than rows, as exemplified by Cassandra. Lastly, we look at graph-based databases designed for relationships. These are highly optimized for queries that involve complex connections, like those in Neo4j. Alright, let us now delve into the core concepts and architecture of MongoDB, exploring its fundamental building blocks and how it operates. We will understand its significant advantages and then look at the various structural elements that make up a MongoDB database. First, let's discuss one of MongoDB's key benefits, which is its schema flexibility, a departure from traditional relational databases. This means that individual documents within a collection do not need to share an identical set of fields. This inherent flexibility allows MongoDB to easily adapt as your data needs evolve over time without complex migrations. Another critical advantage of MongoDB is its robust scalability and impressive performance, especially with large datasets. MongoDB is designed to handle very large amounts of data by scaling out horizontally across multiple servers. It is specifically optimized to perform very fast read and write operations, making it ideal for high throughput applications. Now, let us examine the structural elements, starting with the database, which is the highest level container in MongoDB. Think of a database as a logical top-level container that holds various collections, similar to a schema in SQL. It effectively organizes and isolates your data, providing a clear logical separation for different applications or projects. Moving down, we have the concept of a collection, which is a fundamental grouping mechanism within a database. A collection is essentially a group of related documents, analogous to a table you would find in a relational database. Importantly, unlike traditional tables, a MongoDB collection does not enforce a rigid, predefined schema on its documents. Let us walk through setting up MongoDB and performing your initial operations. We will cover everything from installation to your very first data manipulation. The first step is to download and install MongoDB Community Edition. You can find the installer by visiting the official MongoDB website as shown. After installation, you should verify that the MongoDB server is correctly installed. To do this, simply execute the mongod command with the version flag. Next, you need to start the MongoDB server process to make it operational. Use the system ctl command to start the MongoDB service on your system. Once the server is running, open the MongoDB shell for interactive commands. Type Mongo into your terminal to launch the interactive MongoDB shell environment. Now, you can create a new database or switch to an existing one. The use my database command will either create or switch to the specified database. To add data, insert a new document into a collection. This command adds a user document with a name, age, and email to the user's collection. Finally, you can fetch all documents that are stored within that collection. The find command on the user's collection will retrieve all its contained documents. Let us now compare MongoDB with traditional SQL databases. Understanding these fundamental differences is key to effective data management decisions. Here we see a column for key features of databases. First, let us consider the fundamental structure of the data. Next, we will examine how each database handles its schema. Then, we will look at their respective approaches to scalability. Following that, we will discuss how they manage relationships or joins. Lastly, we will compare their overall flexibility in data modeling. This column outlines the characteristics specific to MongoDB, a NoSQL database. MongoDB stores data in flexible JSON-like documents, offering a dynamic structure. It is schema-less, meaning documents within a collection can have varying fields. MongoDB is designed for horizontal scalability, distributing data across many servers. It does not use joins in the traditional sense, instead favoring embedded documents for relationships. Consequently, MongoDB offers a highly flexible data structure for evolving applications. This column details the corresponding features of traditional SQL databases. SQL databases typically use tables with a fixed schema, defining strict column structures. They require a predefined schema, meaning data must conform to a rigid structure. SQL databases are generally vertically scalable, often requiring more powerful single servers. They rely heavily on joins to establish and query relationships between different tables. Due to their table and schema definitions, SQL databases enforce a strict data structure. We will now cover the essential CRUD operations in the MongoDB shell. This includes creating, reading, updating, and deleting documents, which are fundamental database interactions. Let us start with the create operation for adding new data. The db.collection.insert1 command adds a single new document, while insert many handles multiple documents. This code demonstrates inserting one user document and then inserting multiple user documents at once. Next, we move on to the read operation for retrieving data. The db.collection.find command retrieves all documents, or use find one for a single document with conditions. Here, we see examples of finding all users, finding a specific user, and finding users matching an age condition. Now, let us examine the update operation to modify existing data. The db.collection.update one command modifies a single document and update many works for multiple documents using operators. These examples show updating Bob's age with set and updating multiple user status with a condition. Finally, we cover the delete operation for removing data. The db.collection.delete one command removes a single document, while delete many removes multiple or drop removes a collection. This code demonstrates deleting one user, deleting multiple users based on age, and completely dropping the user's collection. Let us explore Mongoose for structured interaction with MongoDB. It helps in defining schemas, validating data, and performing CRUD operations more effectively. First, let us look at connecting Mongoose to your MongoDB database. You install Mongoose using npm install mongoose, then use mongoose.connect to establish the database connection. This code shows how to require Mongoose, connect to your local MongoDB instance, and handle connection success or errors. Next, we will cover defining a Mongoose schema, which is crucial for data structure. A mongoose.schema defines the structure and validation rules for documents, and mongoose.model creates an interactive model. Here, we define a user schema with fields like name, age, and email, then create a user model from it. Mongoose also provides powerful field validations to ensure data quality. Built-in validators like required, min, max, and enum ensure data integrity, and you can add custom error messages. This code illustrates a product schema with required fields, minimum values for price, and an enum for category validation. Finally, let us perform CRUD operations using Mongoose. Use model methods like save, find, update one, and delete one to interact with documents in a schema-aware manner. These examples demonstrate creating a new user, finding all users, updating a user's age, and deleting a user by name. Now, let us dive into advanced data processing with aggregation in MongoDB. This powerful framework allows us to transform and analyze data directly within the database. At its core, we have the aggregation framework, a robust tool. It allows for complex data processing and transformation operations within MongoDB. This framework is used for efficient filtering, grouping, sorting, and computing aggregate values. Importantly, it significantly improves efficiency by reducing the need for multiple queries. The aggregation pipeline is a fundamental concept here. It is a sequence of operations where each stage transforms documents before passing them to the next. Data flows sequentially through these stages, getting progressively refined at each step. This pipeline is highly optimized for performance, especially in large-scale data analysis tasks. Let us look at some common and essential pipeline stages. The match stage filters documents based on specified conditions, similar to the SQL where clause. The group stage groups documents together for aggregation, much like SQL's group by clause. The sort stage orders the results in either ascending or descending order. The project stage allows you to select specific fields to include or exclude from the output. The lookup stage performs a left outer join operation between two different collections. And the unmind stage deconstructs an array field into separate individual documents. Let us consider an example aggregation to illustrate these concepts. We would filter users older than 25 using the match stage. Then, we would group these users by city and count them using the group stage. Finally, we would sort the results by the total number of users in descending order using the sort stage. This entire process efficiently helps us answer complex analytical questions directly within MongoDB. Let us now discuss securing and optimizing your MongoDB databases. This involves implementing robust authentication and significantly improving query performance. The first step is to create an admin user with appropriate roles for secure access. This code creates an admin user in the admin database, granting user administration privileges across all databases. Next, you need to enable authentication within your MongoDB configuration. Edit the MongoDB file and add the security authorization enabled setting. After making configuration changes, use the system cdl restart command to apply the updated configuration to your MongoDB instance. Now, you can connect to MongoDB using the newly created user authentication. This command connects to MongoDB as the admin user, providing the password and authentication database. To optimize queries, create a single field index for faster data retrieval. This command creates an ascending index on the email field in your user's collection. You can also create a unique index to prevent any duplicate values from being inserted. By adding the unique option, this index ensures that no two users can have the same email. Finally, you can analyze query performance using the explain command. This command shows detailed execution statistics for a query, helping you identify performance bottlenecks. Let us quickly review the key takeaways from our discussion. These are the most important concepts to remember about MongoDB and NoSQL databases. NoSQL databases provide flexible, scalable, and high-performance solutions for data storage needs. MongoDB is a popular document-oriented NoSQL database, excellent for schema-flexible data. CRUD operations, which stand for create, read, update, and delete, are fundamental to database interaction. Mongoose offers robust schema design and validation capabilities for Node.js applications. The aggregation framework enables complex data analysis and powerful transformations directly within MongoDB. Database security is critical, involving authentication, access control, encryption, and input sanitization practices. Remember that indexing significantly improves query performance by optimizing how data is retrieved.